to look at using mass density to find mass or volume. So fun with density. All you need to do is remember the relationship that density is mass divided by volume, okay? And use dimensional analysis to make sure that you are cancelling out your units correctly and stuff, okay? So in this case, 55 milliliters, well, that's a volume, okay, of tetrahydrofuran, and we have the density, and we have it in grams per centimeter cubed. So there is a little bit of a mix match of units, right? Grams per centimeter cubed for the density versus volume in milliliters. Lucky that we know that 1 milliliter is exactly 1 centimeters cubed. So that will allow us to convert between centimeters cubed and milliliters or vice versa, okay? So what we want to do is we want to find the mass. That is the thing we don't have. So if I take this density of 0.889, and that is grams per centimeter cubed. I'll just write the centimeter cubed on the bottom for ease of seeing what we are trying to do here. If I can cancel out those centimeters cubed and convert to grams per milliliter, then I should be able to multiply through by the volume, cancel out the milliliters, and end up with just mass in grams. So this is what I'm going to do. First of all, I've got to get the density in the right kind of units, okay? So I'm going to go from density, this is my plan, density in grams per centimeters cubed. I'm going to go from that to density, density in grams per milliliter, okay? So I'm just going to use that 1 milliliter equals 1 centimeters cubed. That's how I'm going to get from here to here, right? Let's get crazy with this planning here. -3. So that is how I'm going to get from there to there. And then I'm going to get from density in grams per milliliter, and I'm going to get from that to my mass in grams. And how am I going to get that? Well, I know what the volume is in milliliters, so I can use that to convert between density in grams per milliliter to just mass in grams. Okay, so I'm going to follow each of these steps along up here. Okay, so 1 centimeters cubed is equal to 1 milliliter. So yes, the number is the same 1 to 1, but it's really important to show that I'm cancelling my units out. Okay, so now I should have density, if I press equals right now, in grams per milliliter. So then I'm going to make this kind of sync up a little bit. So then if I use my volume in milliliters, which was 55 milliliters, my milliliters will cancel out, giving me just my mass in grams. So I should be there, okay? So what have we got? 0.8899 times 1 divided by 1 times 55 should give me 48.9445 grams. So a couple of things. This is 3 sig figs. This is also 3 sig figs. I don't know why I wrote 2 9s there. I think I got a bit excited. Which means my math is off. Hang on. 0.889. That's what I need. Don't know what. I think I just got a bit excited with the button there. Times 55. So 48.895. That's all we need. Deary me. Grams. Sig figs, we should only have 3 because this is 3. That decimal point makes this 0 significant, and this is 3. Leading zeros are never significant. So 48.8. The 9 here is 5 and above, so that's going to round to 48.9, like so. Okay, so just to draw in my lines and make this look neat, grams per centimeters cubed per milliliter. So you should be able to see that the centimeters cubed cancels, the milliliters cancels, gives me my mass in grams. Okay, so that's how we can find mass from density and volume. Okay, let's do another one just to see how fun it can be. Okay, so we need 20 milliliters of pentane. That's asking the same thing, calculate the mass. Are they all asking calculate mass? Calculate mass. Calculate volume. Let's do that then, something different. Okay. So we've got a mass. Leave the rest of that up. We've got density in grams per centimeters cubed. So this is mass. This is density, and we are asked volume in milliliters. Okay, so first of all, we want to get to what our volume is going to be. So we're going to want to take our mass, 55.0 grams. We're first of all going to get our volume in grams per centimeters cubed. Okay, so if we divide that by our 1.8 0.02 grams per 1 centimeter cubed. Okay, just leave off the 1 because that's going to confuse you. Centimeter cubed. Okay, so I'm just going to write this way round for my units, right? So you can see that the grams will cancel out. The 1's okay. Right, so where's my line? Where's my M, more to the point? No, it all went away. No, user error, old person on computer, alert. So 1 centimeter cubed on the top over 1.02 grams. So all I've done is use this density as a conversion factor, okay? So if you like, I'll write out an equivalency. If thy density is 1.02 grams per centimeter cubed, that means every centimeter cubed in volume weighs exactly 1.02 grams. That's a useful way to be able to use your density to convert between mass and volume, or vice versa. Okay, so grams is going to cancel out, giving me my volume in centimeters cubed, which I do not want. I want volume in milliliters, so I'm going to go ahead and keep calculating. I strongly recommend just trying to do as many calculations as you can on just one line, because you can always make sure your units are cancelling out and stuff, and then you're also not risking making that error of like taking one value that you get at the end of one line and then moving it to the beginning of the next line. You can get transcription error, right? We don't want to do that. So I know from my equivalency, 1 milliliter is exactly 1 centimeter cubed. Okay, so now my centimeters cubed will also cancel out, giving me my volume in glorious milliliters. How exciting is that? So 55 divided by 1.02 gives me big numbers, 53.9215, loads of different sig figs. I should only be giving my answer to, well, this is 3 sig figs, this is 3 sig figs, so I'm going to give my answer to 3 sig figs. 2 is less than 5, so rounding down. And that is what I should end up with, except it's milliliters, of course. So always check your units. And we even ask for 3 significant digits, but it's useful to be able to make those calls yourself. Okay, so hopefully that is enough to get you guys started on that topic.